by any chance any of you were here for my talk yesterday, this is basically behind the scenes of how I did my demo yesterday, essentially. So I want to talk about two tools that I use, Bolt and Vagrant. In my job, I do a lot of infrastructure prototyping. So building a bunch of servers, setting them up to mock out what a server environment would look like with different pieces of software. And oh, who am I kidding? This isn't just for work. I do this for fun too. Anyway, this is the pattern that I have kind of landed on recently, and I think it's interesting, and I hope you do too. Okay, so let's talk about the two pieces. So Vagrant, I don't know how many of you here are familiar with Vagrant, but Vagrant is one of the many products from Hashicorp. It was actually one of their earlier things, but Hashicorp is the makers of Terraform and Vault and just, I don't remember how many other things, Nomad and so on and so forth. Anyway, Hashicorp makes a lot of cool stuff. And what Vagrant does is let you do easy infrastructure prototyping. You can define one or more virtual machines with basically any configuration that you want. CPUs, memory, disks, et cetera, and real quickly spin them up, and more importantly, tear them back down, and then lather, rinse, repeat, right? It has a unified configuration language for VirtualBox, libvirt, and others. It's actually based on Ruby at the moment. I don't know how many of you here are familiar with Terraform, but Hashicorp actually announced recently that Vagrant is going to be moving in the direction of using the Hashicorp configuration language that they use in Terraform. So there will actually be some synergy between those two tools. But anyway, you can find more information at vagrantup.com. By the way, this talk is very slide heavy because I'm going to do a little bit of a demo at the end, but I am going to have a lot of slides. If anything that I'm saying is not terribly clear, any of you who are in the room, feel free to go up to the mic and ask me questions, interrupt as much as you want. I'm fine with that. All right. So the other piece of this is a tool called Bolt. Bolt is from the company Puppet, who makes the tool called Puppet. It was announced a few years ago at their at PuppetConf, and basically started out as kind of their answer to Ansible, being able to do one-off things. Because the thing about Puppet is and I'm a big fan of Puppet, don't get me wrong, but Puppet is really, you're defining a state that you want to maintain over time. It's not really about like, I want to go start up this thing and I want to go start up this other thing, and right. So, Ansible and Puppet to me have always been two different tools for different jobs. Bolt was kind of their answer to that, and initially it was kind of janky, but it had a couple of interesting ideas, and over time it's really grown into this really cool tool that will let you do automation of like starting up a cluster or something like that, where you can go do a thing over here and do a thing over here and do a thing over there in order. But it lets you do, you can use it to run commands and scripts, and also you can actually use the Puppet language configuration. So if you've got Puppet code that'll do a thing, that'll maintain a thing over time, you can use that to bootstrap things, right, using Bolt. So anyway, it's a great orchestration tool. One of the things that I want to focus on actually here is the inventory support. This is one of the cool things about this. It has a pluggable inventory system. So when you combine that with Vagrant, you can define your inventory based on the boxes that you've defined in Vagrant, which is kind of cool. Anyway, you can go to puppet.com/opensource/bolt to learn more about that. So to get started, you need three things. Bolt, Vagrant, and then you need a Vagrant provider, a virtualization provider, because what Vagrant does is spin up virtual machines, right? Actually, what Vagrant does is spin up whatever you tell it to spin up. That can be virtual machines, that can be containers, that can be cloud instances. There are actually other ways of doing this besides just using a virtualization provider. Anyway, the virtualization provider that most people end up using is VirtualBox because it's available basically everywhere. And yes, VirtualBox is absolutely the lowest common denominator. I don't know if anyone's actually a fan of it. It has its limitations, shall we say. I happen to be a big fan of libvirt on Fedora, but when I go over to a Mac, I can't use that, right? So if I so if I use VirtualBox, I can use it on a Mac, I can use it on Linux, I can use it on Windows, whatever. Anyway, you can pick whichever one you want. Okay, so if you've never used Vagrant, the way to get started with it is you create a new directory, you go into the directory, and then you run vagrant init and you give it a box name. If you Google for Vagrant boxes, it'll take you to the site where you can actually find different boxes that you can download. So the way this works, it's kind of like when you're pulling a container off of Docker Hub or something like that. It's basically a pre-configured VM, right? So very, very basic pre-configured VM. Some of them have more configuration than others, but most of your Linux distributions actually ship official Vagrant images. I do a lot of my work on Fedora and CentOS, so usually those are the two that I go after, and they both have official images. You can get images for RHEL and Oracle Linux and SUSE and Debian and Ubuntu and so on and so forth, right? So you just have to find the name of one of those, and you do vagrant init and that name, and it'll create a basic Vagrant file for you. So this file, capital V Vagrant file, in that directory defines the virtual machines that you want to start up. That initial configuration looks like it's got a ton of comments telling you like all the things that you can do in this Vagrant file, but it basically boils down to the 3 lines that are on the screen there. So and again, it's Ruby based, and the most Ruby that you actually have to care about actually is that boilerplate first line that with the do and the pipes. So if you don't know Ruby, it mostly just looks like a configuration file beyond the do and the end in there. So you can edit the Vagrant file and you can define additional virtual machines. So in the example I've got on the screen here, I have that default CentOS 8 box, and I've set it to have a gig of memory when it's running under VirtualBox. So as an example. And then I've also defined a Windows VM. So there are a bunch of Windows Server boxes on the Vagrant site, and also configured that one for a gig of RAM. So once you've done all that, you can run Vagrant up, and it'll start up these virtual machines, and it'll do some basic configuration like set up SSH keys so that you can do provisioning with them and stuff. So again, if you're not familiar with Vagrant, there are lots of things you can do with it. I mentioned Vagrant up, and I mentioned Vagrant init, but there's also a Vagrant rsync. Your current directory by default will actually get copied into the virtual machine so that you can, if you drop scripts or something there, you can actually run them from inside the machine. There's probably the most useful thing is Vagrant SSH. So if you've got just one virtual machine defined in your Vagrant config, you run Vagrant SSH, you'll SSH into that machine. You don't have to know its IP address or usernames or anything like that. It'll SSH right in. There's a Vagrant halt that'll stop all the virtual machines. Vagrant destroy will kill them all. Basically, those two are the opposite of Vagrant up. Vagrant status in a directory with a Vagrant file will tell you what virtual machines are running, or which virtual machines are defined. And then there's a Vagrant global status that will work from anywhere. It's not just looking in the current directory's Vagrant file. There's a .vagrant in your home directory that'll look there and see all the Vagrant configs. So and there's a few others, but I'm not going to spend a lot of time on that. Okay, so that is your almost 10-minute introduction to Vagrant. So let's talk a little bit about Bolt. So with Bolt, you can download, install Bolt, and you can just start using it. You can basically point it at systems using their DNS names, and you have to do no configuration whatsoever, right? But for the purposes of this, I want to kind of tightly integrate it into this Vagrant environment. So in the directory where the Vagrant file lives, I can run bolt project init, or I can do bolt project init project name. It'll use the name of the current directory as a bolt project, and it'll create it with that. But if the name isn't something that is valid for a Puppet class name, basically, letters, numbers, underscore, basically. If it's not that, you might have to say bolt project in it and then give it a friendly name. But that creates two files, a bolt project.yaml and an inventory.yaml. The name of the project gets recorded in bolt project.yaml, and inventory.yaml is basically empty, but that's where you define your inventory. All right. Now, the last piece of magic in all this is a Puppet module called bolt_vagrant. This was written by a guy who actually just recently left Puppet. And what it does is there's a task in it that will, script in it basically, that will go and fetch the configuration of all your Vagrant VMs. And it'll build inventory for that dynamically. So if you run bolt module add and then that name, Dylan Ratcliffe -bolt_vagrant, it'll go download that for you, and it'll update your bolt project.yaml, and it'll drop the module in place and any dependencies that the module has. And then last thing we have to do to set this up is in that inventory.yaml, we have to tell it that we want to use that bolt vagrant module to fetch our inventory, right? So we set our targets to use underscore plugin task, which tells it it's a bolt task that we're going to run. In Bolt, a task is basically a script with some associated metadata. It's pretty simple stuff. And the task name is bolt_vagrant : targets. If you go look up that Dylan Ratcliffe bolt_vagrant module, the instructions are all there for how to set this up too. But at that point, you should be able to run bolt inventory show -t all, and you should see the full inventory. And actually, let's go test this theory, shall we? So I have, this is actually the Vagrant environment that I used for my demo yesterday. So we're going to run this command, bolt inventory show -t all, bolt inventory show -t all. And if the demo gods are smiling on me today, we see I have targets, Puppet, Agent, Gitlab, Runner 01, Runner 02. So those are all of my VMs that are defined in my Vagrant file, and that's generated on the fly. All right, so now, once all this is set up, we can start to use Bolt against all those VMs, right? So for example, if we run bolt command run hostname -t all, it will run the hostname command on all of your targets, right? So the -t all is telling it, -t for targets, all is all of your targets. I can also say, -t and then give it specific targets. If I want to run it on, on one or more, I can do comma or space separated, basically, after the -t. But if we go over here, I can do bolt command run hostname -t, like I have, there's a Gitlab target, right? So I can say just run on the Gitlab target. And so what that does is that actually SSHs in, runs the hostname command, and then spits out the output. So that's one thing you can do with Bolt. The next thing you can do with Bolt is you can run arbitrary scripts. So if you've got a script, you can say Bolt script run and then give it a path to the script. And then again, you tell it what targets you want to run against. So in this example, if you'll recall early on, I had a Vagrant file with a CentOS and a Windows VM, right? So the nice thing about running the hostname command is that actually exists on both Windows and Linux. That's why I was using that in the example. And in this example also, if we write hostname out to, myscript.ps1, then we can run Bolt script run myscript.ps1 on all of the targets. On Linux, nobody cares what the extension means on the file. On Windows, that'll tell it to run it with PowerShell, and it still works. So this is one of those rare cases where you can do something that will actually work on Linux and on Windows. So I'm not going to do a demo of that. Anyway, I mentioned running tasks. So Bolt tasks are scripts with some associated metadata. I can show you an example of some tasks as we go along later. I'll go into some code. But there's actually a bunch of tasks that are shipped with Bolt, and you can run Bolt task show to see those. I actually will show you that real quick. So if we do Bolt task show, what we will see, let me make this a little wider, is there's a bunch of stuff. So we see our Bolt _ vagrant : targets task, which is what we're using to generate our inventory. And there's a couple of GitLab related tasks because I've got a GitLab module dropped into here. There's like a package task, so you can install and remove packages with as a task. And various other things. I can mess with the Puppet agent and reboot systems and things like that, managed services. Those things are built in to Bolt, and then you see things like this, these role : things. Those are ones that I wrote to build my GitLab environment. So, okay. Anyway, to add additional tasks, you can install Puppet modules, or Puppet modules that contain tasks, that is, or you can create a directory named tasks and drop in the necessary files. So basically, every task has the implementation of the task, the script or whatever associated with it, and then it has a JSON file that basically defines like what the parameters are and whether it supports the no-op flag, and there's not a whole lot to it. Again, I'll show you examples in a few minutes. Whoops, that's not the thing I wanted to hit. I wanted to hit this. Oh, hey, that's right. I have an example right here. So this is what it looks like. So the JSON that describes the thing, it says Puppet Task version 1. This particular thing doesn't support no-op. The description, which is what shows up when you do the, on the right there, whenever you do the Bolt task show. And then in this case, I have a fun thing with implementations. So that thing where I was saying I was running stuff against Windows and Linux, and that that only works so far. There's only so many things you can do on both. Well, the way that you handle that, if you actually do want a task to be able to run on both, or on multiple operating systems or whatever, is you have this implementations block in your JSON, and that actually tells it which script to run for which platform, right? And so in this case, I'm saying if I have a shell, run hostname.sh. If I have PowerShell, which is only going to be on Windows, then use hostname.ps1. And then if I had parameters to the script, they'd be listed in this parameters block, and it actually lets you do data types like you would in Puppet, where you can say this is a string or this is an integer or whatever. And then the rest of the pieces are the actual scripts themselves. So in this case, I have a very simple hostname.sh on the right there, which just runs hostname, and hostname.ps1, which just runs hostname. So again, very insanely simple example, but hopefully you get the idea. So anyway, once you have all those files in place, basically, then you can just run bolt task run, and then the name of the task, and then again, specify the targets, right? And if you have any parameters, then you just specify those, key equal value at the end, and those get passed into the script either as environment variables or as a JSON blob, depending on how you configure some things. Okay, now, all of that is very cool, and most of that actually worked with that very first version of Bolt that I said was kind of, iffy, but definitely, definitely something interesting, but, anyway. Where Bolt started to get really interesting for me was this concept of plans. So Bolt plans are a set of commands, scripts, tasks, or other plans that run in sequence. Now, what's really cool is Bolt actually supports two different kinds of plans. You can either do a YAML plan, which is going to look a lot like the way you would do things with Ansible, or you can write plans in the Puppet language. Now, for those of you not familiar with Puppet, the Puppet language is actually kind of cool. It's kind of turned into this functional programming language. And so there's some really cool stuff that you can do with it. And so plans written in the Puppet language, to me, are just awesome. I can do some really cool stuff. And again, I'm gonna get into some examples here when I get done setting the stage for you all, assuming I have time. Okay, so if you want to write a plan, you can, unfortunately, there's no Bolt command to generate a task for you, which is weird, but there is a Bolt, there is a Bolt command to create a new plan for you. So it'll lay out the basic plan. So you can either run Bolt plan new and then your plan name, or you can run Bolt plan new, the plan name, -pp. So if you don't have the -pp, it creates a YAML plan. If you have the -pp, it gives you a really basic Puppet language plan that you can start from. Or alternatively, you can just add the YAML file or the .pp files to a directory named plans in the Bolt project. So here's an example of a YAML plan. When all this is on YouTube later, if y'all want to prove that all this stuff works, go for it. If you follow along with all the code in the slides and copy, or well, I guess you can't copy paste, but there's a blog post with actually all of this information that you can find if you dig a little. If you copy and paste the bits from it, you can actually walk through this whole thing and kind of see how the whole thing works. Anyway, so for our YAML plan, we're going to basically give the description for it. We're going to say what the parameters are, which basically all we're taking as parameters are the list of targets to run on, in this case, and then we have steps. So and this again, this is the plan that's generated by Bolt, and so basically it's just it spits out a message hello from this plan name, and then I've added a command step that runs hostname on all the targets, right? So every one of these examples does exactly the same thing. And I know they're just getting progressively more complicated, but that's also because we could do a lot more. And I, again, will show you. So our Puppet plan looks like this, where we have the plan and then the plan name. We specify as a parameter to the plan the targets we want to run on. We call the out : message function to spit out a message, and then we do the run command function in order to run the command hostname on all of our targets, and we return a result. Running those looks an awful lot like running everything else. You do bolt plan run and then the plan name. In this case, we don't have to give a list of targets. We can. We don't have to, because in our previous example, we defaulted to a target list of all. So if we don't specify the list of targets, then it just runs on all of them. Okay, now, we talked about Vagrant, we talked about Bolt. Now we talked about that, the Bolt Vagrant plugin that lets us tie the inventory together, right? Now, the last thing that makes this super cool to me is actually using a Bolt plan for provisioning. So if you're not familiar with Vagrant, one of the things that you can do is you can like have scripts in line or point to scripts on the file system to have it run. It copies everything over to the /Vagrant directory on the VM. It runs the scripts. You can do all kinds of crazy stuff. And I've got all sorts of examples where I did all kinds of crazy stuff with shell scripts and whatnot. But what we can do is we can completely disable copying the /Vagrant directory over, and we can just run a Bolt plan that does everything for us. We have to enable one experimental Vagrant feature called typed_triggers. And you do that by setting an environment variable. Well, it just so happens you can just set the environment variable in the Vagrant file because, again, it's just Ruby, right? So we can set env vagrant_experimental equal type triggers. And that lets us do the next thing we're going to talk about, which is configuring a trigger. So what we're going to do is we're going to configure two triggers. We're going to configure one for before certain commands run. So in this case, we're saying config trigger before up, provision, and reload. So those are the commands we're going to add this trigger to. It's going to run this. It's going to run the trigger.run equal inline bolt module install. So we want to do a bolt module install because if you grab this whole thing and we've added plugins like that Bolt Vagrant plugin, we need those modules downloaded and ready, right? So bolt module install with all of the other configuration available will go fetch all those modules for you. So we need that to happen before we do anything else with Bolt. And then the other thing we want to do is we want to run a trigger after this is run. So we define all of our virtual machines. We do a Vagrant up. Vagrant spins up all the virtual machines, and then it runs Bolt plan run, and then the plan name that we want to run with this trigger in place. So there are lots of examples of this. Well, lots. I think 4 or 5 that are on GitHub. They are all mine, but I tagged them all with the same tags so that you could actually see those individual things. All right, we are right on time. So what I want to do now is switch over and actually show you a little bit of what one of those things looks like. So this VS Code window back here that I need to blow up. This is actually this is the demo that I did yesterday. Okay, those virtual machines that are running in Vagrant are the virtual machines that I was running. And all of this, by the way, is on GitHub. You can find it by using the search terms that I had in the last slide. Go back to that real quick. The search terms are puppet-bolt and vagrant-environments. So you can find those on GitHub pretty easily. Also github.com/silug, S-I-L-U-G, that's me. So anyway, all right, so let's look at the pieces of this. So there's a lot more to this particular thing because I've got it doing a lot of stuff and this is pretty fleshed out. But if we go down here to our Vagrant file, this Vagrant file is not substantially more complicated than what we had there. I have a little bit of extra stuff because I have some configuration options. Like I can actually like change the box that I'm using. I have the ability to run to use a cached GitLab RPM because the first time that I tried to work on this when I wasn't on my home internet. I realized that 10 megabit Wi-Fi trying to download a 1 gigabyte omnibus GitLab package was a little slow. Yeah, took a while. So I'm like, okay, I'll download that once, and then I'll just copy it over to the VM, and I'll go from there. So there's a little bit of extra code in here to do that, but most of this is just defining my virtual machines, right? So I do a little trick here where I'm actually setting up for either VirtualBox or libvirt. I'm running libvirt locally. Libvirt's a lot faster if you've got a Linux machine. Use libvirt. Don't use Vagrant. You'll thank yourself. True story? Yes. Confirmation. Anyway, so I have my Puppet virtual machine, and I'm giving it 3 gig of RAM, 2 CPUs. I'm setting the host name, a little bit of configuration there, right? And I'm also setting up a private network on each one of these so that they can talk to each other. And then I define an agent, which I never used yesterday, defining my GitLab server, giving it 6 gig of RAM, 2 CPUs, and then I've got a couple of runners with 4 gig of RAM and 2 CPUs each. So like I said, most of this is just setting up all of my virtual machines. And by the way, the little bit of Ruby that I am doing in here, I am going to super miss when they do move over to the Hashicorp configuration language. I'm going to have to figure out how to do all that with that language again. I've done Terraform, but it's been a minute, so I got to go remind myself how to do that. Anyway, and then there's that before trigger that does the bolt module install, and then afterwards I'm running a plan named roll, but I'm actually passing some parameters into it. One of the parameters I pass in is demo equal true. So I started trying to refactor things so that the demo environment builds with some defaults set. But if you ran this plan against real systems, then it wouldn't do the weird defaults that make sense only when you're running in Vagrant, like the port redirection and stuff like that. So I started trying to refactor this a little bit, which actually, by the way, is a point that I kind of didn't make in my slides. One of the things that's cool about this is I can prototype all of this stuff out using the bolt plan. When I'm done, I can just run the bolt plan and set the targets to real hosts, right? So if I've done it right, and I'll tell you honestly, I haven't done this right because I haven't tried running it against real systems, so I know I've still got some Vagrantisms in it. But if I can strip that out, when I'm done, I should actually be able to run this bolt plan with a target list of a GitLab server and a Puppet server and some runners, and all of the right things should just happen the exact same way that they happen in Vagrant. That is the ultimate goal here, right? Because the thing is, all of my prototyping before, where I was just writing a bunch of shell scripts, if I wanted to do that on a real system, I had to go back and then go figure out how to copy those scripts over and run them in the right order, and and again, strip all the Vagrantisms out of them and whatever else. It just showed me how it showed me how it would work. It didn't show me exactly how to do it, right? So my eventual goal is to make all of these projects that I have on GitHub work for real. So you could point them at a real system. And at the moment, they're all in varying states of that. And by the way, in fairness, I think I figured out how to do all this in the last 8 months, maybe, I think. So this is still a relatively new pattern for me. I'm still sorting it all out, but I still think it's cool. Okay, so that's our Vagrant file. And in this thing, I've got more Puppet code because, again, it actually started life as a thing to build a Puppet server and show how to bootstrap a Puppet server. I actually talked about this project, an earlier version of this project, a couple like 2 or 3 years ago. I don't remember exactly. I had to talk about building about bootstrapping a Puppet server and what that looked like. That was all done with a bunch of shell scripts and stuff in the Vagrant config. And I refactored that whole thing to use Bolt. So that's one of my sample projects out on GitHub. when I was building this, I actually just grabbed that, tacked on the GitLab server and some of the CI automation to that project. So if you look at the Git history on this thing, it goes back a number of years. But anyway, so my main plan is actually very, very long. 247 lines. It's not that long. This is, this is kind of first attempt at this. I haven't gone through and really, really, really tried to clean this thing up yet. But anyway, what I started to do though is like say I have a parameter that's $demo here, and then I set some things based on whether $demo is set or not. So like the this user, I use the Vagrant user if it's in the demo environment, but otherwise it sets it to undefined. But anyway, so this is what the Puppet language looks like. I have some code in here to set the Puppet version, because that was another thing that I wanted to do with that other that Puppet server environment, is I wanted to be able to like show what it looked like with Puppet 6 versus Puppet 7, things like that. But where it gets fun, this is my favorite part here. So I have this snippet of code that actually goes out to one of the first things it does is it goes out and hits every system and it grabs their facts. So in Puppet, you have this concept of a fact, right? So things like the host name, the IP address, the whether the system's virtual or not, things like that are all facts. And you when you're writing Puppet code, you use those facts to do a lot of logic, right? So what I do is I go and I fetch the facts from a system, and then I iterate over all of those targets, and I grab the IP address of the last network interface that has an IP address associated with it, and I store that. And I also store the host name of the box and the AFQDN. And then I have a little snippet of Puppet code that goes and sets host entries on every box for the IP address and the host name, the fully qualified domain name and the short host name for each one of the systems in the target list, right? So if we actually were to look on any one of these VMs, you'd see that they have defined host entries for GitLab and Puppet and the runners and whatever else, so that I can use host names, various places, and things just work, right? Without having to have working DNS. So that was a fun one that I figured out how to do. And then I just kind of start diving in and start doing stuff, like I copy my GitLab package over and install it. And I've got a task that imports my controller. Basically this repository gets copied into the GitLab server. And that's done with this shell script that does lots of JQ. Anyway, lots of things. But it's just a shell script. That shell script has this JSON file associated with it to define the task. So again, tasks are pretty simple. Where did I clicked away and there it is. Anyway, so again, this is somewhat involved because there's, in order to, bootstrapping things is hard, and that's one of the reasons why I love prototyping things with Vagrant, because then you figure out, oh, I have to do this thing, and then I can do this thing, and then I can do this thing, right? And when you build all this stuff by hand, a lot of times you just know, well, I got to go over here and I got to do this thing, and then I got to go over here and do this thing, and then I got to go back over here and I could do this thing. And or over time, like you've built something and you've iterated on it, and you don't actually remember like all of the steps to get to the point you're at, right? So I love capturing that stuff with Vagrant and being able to say this is exactly the steps to get from 0 to finished product, right? So anyway, I have, if we go back to here, I actually have this. This is that the search page on GitHub that shows those things. So apparently I have 4 repos at the moment. So the one that we're looking at in VS Code is this GitLab Puppet thing. I actually have one for spinning up the compliance automation software that we use. Basic AIO is actually the project that my GitLab thing was based on. But something completely different that I have is I have one that spins up a couple of systems and sets up a Samba 4 domain controller. I actually have one more project that isn't showing up on that search page because I haven't merged the changes yet. That sets up an active-passive firewall pair using CentOS and Keep Alive D and Contract D and various other things. It's actually, I actually wrote this with all shell scripts and everything else and demoed it for a users group meeting like 4 years ago. And since then figured out how to puppetize all the bits of it, and I actually use it at home. Anyway, I'm circling back around and taking the Vagrant demo that I did and trying to use this pattern with it. I just haven't merged the changes yet, so I hadn't gone back and re-tagged that. But I'll get to that now that I'm remembering that that's a thing that I need to do. But anyway, I have gone on now for 40 minutes, so surely someone here has a question for me. Anybody, help me out. All right. Yeah, if anyone has, if you have a question, there's a mic right there.
So for those that were at the talk yesterday, how long does it take with like a Vagrant up to actually spin up that full GitLab environment with runner and Puppet server and everything else? All
right. So on my beast of a laptop that I just got, it takes about 14 minutes for that whole thing to spin up and do all the things. On my slightly less beefy desktop at home, it takes about 17 and a half minutes. So I have some other Vagrant environments that take like, half hour plus to spin up. I should mention one of the other reasons why I started going down this path is with Puppet code, one of the cool things about it is that it is eventually consistent. So you try to write your Puppet code so that when it applies, it it gets everything into the end state that you want on the first run. But if it doesn't, it'll just keep doing things in order to get closer and closer, and it'll converge on the state that you want, and then it'll maintain it, right? So if you're writing a lot of this stuff using Puppet code, you can rerun the provisioning over and over again. And as you're iterating on, trying to figure out how to set all this stuff up, you can just run it over and over again. When I historically have done things with Vagrant, I would modify scripts and stuff, I would tear the whole thing down, and I'd start all over again, right? So when you start getting into environments that take, 15 minutes, 30 minutes, an hour to spin up, right? It starts to get really obnoxious in order to iterate by tearing the whole thing down and completely starting over, right? So using Bolt, I can do a lot of my iteration by just rerunning the Bolt. I actually can just run Vagrant up again. Like I can make changes to the code. I can run Vagrant up. It won't do anything with the virtual machines, but it will run the provisioning trigger again, right? Which runs the Bolt task for me. So I don't have to remember how to run the Bolt task off the top of my head with all the parameters and stuff. I can just run Vagrant up and boom, the thing happens. And in a lot of cases, if I'm, especially when I'm getting close to being done, instead of taking, 14 minutes to do that one thing that I added to it, it might just take, 30 seconds, right? So it saved me a lot of time. So that was kind of cool. Anyway, any other questions? I feel like I have bored everyone to tears. I know this talk's a little deep in the weeds, so I wasn't sure how everybody would feel about it. You know, this is something I've been living, sleeping, eating, breathing for, like, you know, I don't know, a while now. Hopefully I did it some justice. So, but all this will be on YouTube, and if you're interested, the company that I work for, Secura, we've got a table right out here. The QR code on the left will take you to the Secura site. The QR code on the right is my LinkedIn profile. You can feel free to message me if you want more information or whatever else. Or if you want some help with doing some server automation and compliance stuff, feel free to ping us over on the other one too. If there aren't any more questions, then I guess I'm done. So thanks, everybody.
Thank you, Stephen.